Section 8.2 is another special right triangle section. We're going to start off with a little bit of review. A little bit of review of what we covered in 8.1. So in this section, we have the Pythagorean theorem, and we've done that before where it's a squared plus b squared is equal to c squared. And you can use that to find missing sides when you have a right triangle and you know two of the side lengths. One thing you need to remember is that C has to be the hypotenuse. And then we talked about the converse of Pythagorean theorem, where we can use this to determine if we have a right triangle, obtuse triangle, or an acute triangle. And we know that if c squared is equal to a squared plus b squared, then it's a right triangle. If the c squared value is larger than a squared plus b squared, then it's obtuse. And if it's smaller, then it is going to be acute. The other thing we covered last time was the special right triangle when it is a 45, 45, 90. So this happens when we have a right triangle that is also isosceles, so both of the legs are going to end up being the same length. And for this one, the legs are again called the legs, and then we have the hypotenuse. And the one formula or equation that you need to remember for this one is that the hypotenuse is equal to the leg times the square root of 2. So then we are able to use this to find missing pieces in our special right triangles. All right, so that was a little review from 8.1. With our next part, we're going to practice simplifying operations with radicals. The first one, we have the square root of 3 times the square root of 3. When you multiply two square roots together, you multiply the values that are underneath the radical. So for this one, we would do 3 times 3, and that equals 9. And the square root of 9 is equal to 3. So if you can recognize that you're multiplying the same square root times itself, that is the same thing as squaring it, or taking the square root of 3 squared. And those are inverse operations that cancel each other out, leaving you with the value underneath the radical. All right, our next one, we have 5 square roots of 3 times the square root of 3. So with this part, we just went over how that is equal to 3. The 5 up front is being multiplied by it, so we would have 5 times 3, and that gives us 15. Another thing that we talked about on 8.1 is how we have to rationalize fractions if we have a square root in the denominator. So only if the square root's on the bottom. So we're going to take both of these and multiply them by the square root of 2 on the top and the bottom. And that gives us 7 square roots of 2 over 2. This one cannot be simplified any further because 7 divided by 2 would give us a fraction or a decimal. If you would like to write it as 3.5 square roots of 2, that would be okay, but both of these would be acceptable for full credit on a question like that. Okay, so then that brings us to the new part for today. Today, we're going to go over our 30, 60, 90 triangles. So this is, again, another type of special right triangle that you are going to need to know. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So just reading the definition, it's kind of confusing to keep track of all that. So we're going to draw a picture. In the picture, we have a right triangle with one angle that is 90 degrees. And then we would have an angle that is 30 degrees and 60 degrees. And in a previous chapter with triangles, we talked about how the longest side is always opposite of the largest angle, and the shortest side is opposite of the shortest angle. The first thing that you should label in this is your hypotenuse. That is always going to be opposite of our largest angle, the right angle. And then we have two legs in this one. And unlike the 45, 45, 90, the legs are not going to be the same length. So the way that we're going to label them is the one opposite of the 30-degree angle is going to be the short leg. And we're going to abbreviate that SL. And then the side opposite of the 60-degree angle is going to be the long leg. And we are going to abbreviate that one LL. So we have three different sides, and anytime you have a 30, 60, 90 triangle, I'd recommend labeling these so that you can recognize the parts. So we have our hypotenuse, short leg, and our long leg. Then the formulas that you are going to need to know. Let's start with the hypotenuse is twice as long as the short leg. This one is going to be the easiest. So your hypotenuse is equal to 2 times whatever your short leg is. And then the next part that we would need to know is that the longer leg is the square root of 3 times as long as the short leg. So LL, our long leg, is equal to the short leg times the square root of 3. And these are the two equations that you are going to need to remember for your 30, 60, 90 triangle. And with the 45, 45, it was the square root of 2. And you could kind of think of there are two sides that are the same. And this one, there's the 3 under the square root. All three sides are different. So those are the things that I use to help me remember, am I supposed to use the square root of 2 or the square root of 3? All right, so now we're going to do some practice with 30, 60, 90 triangles. With these, you're going to find the values of x and y and write your answer in simplest radical form. The first thing you should do is label your picture. Always start with the hypotenuse. Once you get that, it's pretty easy to figure out which one is going to be your short leg and then your long leg from there. So short leg is always opposite of 30, long leg is opposite of 60. And our two equations we have is that the hypotenuse is equal to 2 times the length of the short leg, and our long leg is equal to the short leg times the square root of 3. So if we look at what they gave us, this is going to tell us what equation we're going to start with. They told us the length of the long leg. So we're going to go ahead and plug that into our equation. Our long leg is 8, and that's going to be equal to the short leg times the square root of 3. And our goal, we need to figure out what the short leg is equal to. So we're going to divide both of these by the square root of 3. And in the beginning few problems, we went over how we cannot have a square root in the denominator. So once you get here, do not forget to rationalize your answer. So we'll multiply both the numerator and the denominator by the square root of 3. And that gives us 8 square roots of 3 over 3 is equal to the length of our short leg. And that would be our answer. Awesome. Once you know the short leg, then it's pretty easy to figure out the length of your hypotenuse. So we're going to take that and plug it into our formula for the hypotenuse. So the hypotenuse equals 2 times the length of our short leg. And our short leg is 8 square roots of 3 over 3. And when you multiply a whole number, the 2, multiplied by a fraction, Remember, you only take that whole number and multiply it by the numerator, so top times top. And that will give us that the hypotenuse is equal to 16 square roots of 3 over 3. And that would be our answer. So really for these problems, it's solving equations. What you need to know and make sure you remember is the two formulas on how to set them up. If you can remember those and you're good at solving algebra equations, you should be good to go. All right, our next example, you make a guitar pick that resembles an equilateral triangle with side lengths of 32 millimeters. For this one, we'll start with a picture. Equilateral means all three sides are the same, which also means all three sides are 60 degrees, or all three angles are 60 degrees. They want us to find the approximate height of the pick. So the height is one of the altitudes. So we're going to draw that in here. And the heights, again, are formed with right angles at the bottom. In an equilateral triangle, when you draw an altitude, it's also cutting the opposite side in half. So the original length was 32, and half of 32 is going to be 16. Now, if we look in an equilateral triangle, we know all of the angles are 60 degrees. And when we drew that altitude, we made two smaller triangles. And if we look at just one of those, we'll notice that it is going to have an angle that is 90 and an angle that is 60, which leaves this top angle of this yellow triangle to be 30. So we have a 30, 60, 90 triangle. And if we labeled our hypotenuse and our short leg, you'll notice that the hypotenuse was 32 and our short leg was 16. And if we plug that into our formula, we would get 32 equals 32. So the hypotenuse is twice the length of the short leg. Then we need to figure out the length of the long leg. And the formula for the long leg is the short leg times the square root of 3. And the short leg was 16. So this one doesn't require much work. It is just going to be 16 square roots of 3. And sometimes it's going to be that easy where you either multiply it by 2 or you just add a square root of 3 after the number. So these are kind of the two different examples of how much work you'll have to do. Either it'll be like example 1 where you have to do a little bit more algebra, or this one where you just put in the number and you're done. All right, so we have two more examples. I would recommend pausing and trying them on your own and then checking your answers. Remember, always start with labeling your triangles. So we have our hypotenuse, short leg, and our long leg. And then you would want to write out your two equations. All right, so if we look, they gave us the length of the short leg. So the short leg is 2 square roots of 3. And just like last time, even though there's a square root of 3, we still have to include the square root of 3 to get the length of the long leg. And this looks like one of those simplifying radicals that we did earlier at the beginning of the notes. The square root of 3 times the square root of 3 is just 3. So then we're going to end up with 2 times 3, and that equals 6. So the length of our long leg is 6. It doesn't ask for the length of the hypotenuse, but we're going to go ahead and find that as well. So our hypotenuse is 2 times the short leg, or 2 times 2 square roots of 3. And you would just multiply together the values that are outside of the square root sign. So 2 times 2 is 4. So our hypotenuse would be 4 square roots of 3. Okay, And the last example, find the value of h. This one is very similar to example 2. You can tell that this is an equilateral triangle, the larger one on the outside, because all three sides are 12, which tells us these two base angles are both 60 degrees, giving us a 30, 60, 90 triangle here. So then the 6, that's going to be our short leg, 12 is our hypotenuse, and 60 is the long leg. And we know that our hypotenuse is equal to 2 times the short leg, and then our long leg is equal to the short leg times the square root of 3. And they want us to find the height, and that is the long leg. So this is what we are looking for. Our short leg was equal to 6, and we just multiply that by the square root of 3. So that would be our last answer. Okay, when you go through and work on the homework, make sure you are not just assuming it's a 30, 60, 90 triangle. You do have to figure out if it's going to be a 45, 45, 90 or a 30, 60, 90. So make sure you can tell the difference. So if they have two sides that are the same, like number 2, that one is the 45 one. And then if they don't have the same leg lengths, that is when you have your 30, 60, 90. So you're going to get practice with both of them today. And sometimes they're going to have multiple triangles together, so just try your best. And then when I am back on Friday, we can go over questions.